Hello there, this is the Computer and Architecture Organization, and today we're gonna talk about interesting subjects. First, we're gonna talk about ASCII code. And what is ASCII code? Why ASCII code is represented by 8 bits, and is there another system just like ASCII code? And we're gonna talk about the memories, just like RAM, cache, registers, and we're gonna talk about the computer itself. What does computer consist of? And then we're gonna talk about how does any computer work, and we're gonna talk about the CPU, its components, and its development stages, as well as we're gonna talk about a small tiny introduction to the assembly language and its advantages and disadvantages, which is the pros and cons. So be there. We're gonna start with the ASCII code. What does ASCII code mean? First, the ASCII code, it's actually a shortened word from other words. So what does ASCII code mean? ASCII code is American standard. It is American standard code for information interchange. And what does it represent? What does this ASCII code represent? It's simple. It represents all the English alphabets, the digits, the special characteristics, and maybe there are other things that I missed. But in general, it represents everything that has to do with English. So why ASCII code is represented by 8 bits? ASCII code is represented by 8 bits. Why? If the bits of any characteristics is 7 bits, why the 8 bits is taking a place? Actually, most of us know that any characteristics is represented by 7 bits, and there is 1 bit is added to the code itself, which is for the signal. It determines that is it positive or negative, and sometimes it's used to determine which the code is odd or even, and so on. The third point about ASCII code, what about other languages? Can they be represented? It means that there are another languages such as Indian, Chinese, Arabic. Can they be represented? Can't we find them in in programming languages? Actually, there were many Asian countries that they gathered together and they come up with the UNICODE. It's just like ASCII code, but it is represented by 16 bits. Some of you may ask, why? Why 16 bits? Actually, it is represented by 16 bits since that they bought a word or something, a characteristics, and they bought a translation for it. For example, A, it's A. And if we talked about Arabic language, what is similar to A is Alif. So if we put A, we need to translate it to Arabic, A and Alif. So it's gonna be 8 bits plus 8 bits, which represent 16 bits. The other thing we're gonna talk about today is memories. We're gonna talk about 3 types: RAM, cache, and registers. First of all, RAM. It's a shortened word of 3 words, which are random access memory. So what's the definition of RAM? RAM is a memory used to store information that needs to be used quickly, which means the data that are gonna be, or the information that are gonna be stored, they are stored temporarily. And when it comes to cache memory is a small size tab of volatile computer memory that provides high-speed data access to processor and stores frequently used computer programs, applications, and data. What I'm gonna say about RAM and cache memory, that they are volatile, which means that they are temporarily used to store data or information. and they are, I think, when it comes to memory, we must mention RAM and cache memory. And the third one is registers. Register memory is the smallest and fastest memory in a computer. And there are 3 points that cannot be missed about registers. First of all, it's not a part of the main memory. Okay? It means that it's not in the memory. It doesn't locate it in the memory. It doesn't locate in the memory, sorry. And instead, it's located in the CPU. It's located in the processor. Okay? The second point is that it provides the privilege of fast access. That means registers were made for a purpose. That purpose is fast access. The last point is that there are 16 addresses and registers, and each has a specific job. That was a short background about registers. It's not I mean like 10% about registers. If you need more information, you can research, or you can ask me anything in the comments. Now let's talk about computer itself. Computer has components. What does it consist of? Actually, no two programmers can argue on this. Computer components are basically hardware and software. So, the hardware. What does hardware consist of? Actually, it consists of 5 basic components. First of all, input devices. So, anything that provides the privilege of enter anything to the computer is input devices. Such as what? Okay, for example, keyboard, mouse, mic, and other peripherals and other devices. The second component is output devices. Anything that comes from the computer or is showed up from the computer, it is output devices. Such as what? Okay, for example, the screen itself, it exposes anything that the user makes, the interfaces to the user. Another thing is the speakers or other devices. The third component is storage devices. Anything that we use to store data or information as storage devices. For example, hard disk, flash drive, SD memory, and so on. The fourth component is communication devices. When it comes to communication devices, it cannot be missed that buses are the most important communication devices. They move data inside the computer. They move the information between one device and another, and so on. And the last component is the system unit. I think it's extremely and super important because it covers all or the most important devices in the computer. It consists of the the CPU, the memory itself, and a lot of devices that it protects them. Sorry, it protects them. So anything that is devices, it's hardware. So what about software? What is it? Software are interfaces of systems, programs, or applications. So anything that is a program or a system or an application is a software. Any interfaces is a software, and any device is a hardware. And now we're gonna talk about how does the computer work. Actually, anything or any action that comes from the user, it goes through stages. 3 stages. The first one is the hardware. So any action that the user does, it goes first to the hardware, and after it goes to the hardware, for example, a click on a mouse. That's what I'm doing now. It's a click on a mouse, or moving the mouse around, like just what I'm doing. This is an action. So what's happening now? First of all, when I put my finger into the mouse, I'm moving it, so it goes to the hardware to take my action as moving, for example, and after that it goes to the RAM to take a place temporarily. And after that, what's gonna happen? The RAM is gonna send an order to the CPU. This moving or the user is moving their hand on the mouse mat, for example, and there must be a result. There must be something that's gonna show up. For example, if we say that the CPU is the main or the most important one of these. Why? Because it process what's gonna come from the RAM, and it gives the results in back to the RAM in an inverse way. So the action is first going to the hardware, then it's going to the RAM to take a place, then the RAM is gonna send this order to the CPU to be processed, then after that it's gonna be an inverse way from the CPU. The order is gonna be sent to the RAM, then after that it's gonna be sent to the hardware, then to the user, to the screen, to see what he has done. And this operation is happening in a part of a second. Can you imagine that? It's really amazing, and it's really magnificent and breathtakingly incredible. After that, we're gonna talk about the CPU. Okay, what are you, CPU? CPU is a shortened word of 3 words, which are Central Processing Unit. And what's the definition of the CPU? CPU, actually, it's a thin printed circuit that holds the most important components in any computer. So the most important components in any computer are being held by the CPU. So what are these components? We're gonna talk about this later. One more point about CPU. CPU is responsible of translating and processing instructions and orders that come from the hardware and software, and transform these orders and instructions into binary outputs 0 and 1. What the heck that means? It means that anything that the user does, as we talked about before, that first it goes to the hardware, then it goes to the RAM to take a place temporarily, and then it goes to the CPU to be processed. The processing here is that it's a mix of translating and transforming the orders, or the order that has come to the CPU, and make it as a result that consists of 0 and 1 series of outputs or binary outputs, and then send it to the RAM, and then send it to the RAM sends it to the hardware, and then shows it to the user. The third point is that CPU, it consists of millions of transistors and semiconductors. What are transistors or semiconductors? Actually, they are a long-term subject to talk about. Maybe we need a video or two to talk about transistors or semiconductors. I suggest that you can research for it, and if you have any question or specific question, you can ask me in the comments. The last point of the slide is that what is a CPU made of? Actually, CPU is made of silicon. Why is that? This is gonna be a question for you, like a quick test. You can answer and put the answer into the comment to see that who is smart or not. So it's made of silicon and has plenty of golden pointed heads. And now this is the reason that explains why CPU is expensive. A lot of people were wondering why CPU is expensive while it has a small tiny size. And this explains why, because it has heads, pointed heads that made of gold, and that explains why. Now let's talk about CPU components. Actually, there are three basic components, which are the three ones in order, and the last three ones are, they are not basic, and they differ from, as we said, three basic components and three not basic components. And by not basic, I don't mean that they are not important. They are super important. Let's talk about them one by one. First of all, ALU, which is shortened for three words, which are arithmetic logic unit. So what do you do, ALU? Actually, ALU does all the arithmetic operations, such as summation, subtraction, multiplication, and division. And when it comes to the logic, where it does a lot of things, such as the logic stuff, or, and, greater than, less than. So it's super important. The second component, which is the registers, we talked about registers, and we say that they are the smallest and fastest memories, and they are located in the CPU but not the memory. And we said other stuff, and it's a long-term subject. If we need to talk about registers, we need a long video. So the third component is control unit. What does control unit do? Control unit actually its function is from its name. It controls all the operations, and anything that needs control in the computer, the control unit does this control. And it's super important, and that's what we put it with the that's why we put it with the three basic ones. The not basic ones, the input and output unit, which does an important function, that is, it takes anything from outside the computer into the computer, and the opposite, anything from the computer into outside the computer. So it's super important. The clock does an important work, which controls the timing in the computer. So it's really important, and we cannot use any system without a clock. The last one is cache. We talked about cache. We said that it's small memory, and it's located between the RAM and the CPU, and it does or it provides the privilege of fast access. I think that was a short explanation about the CPU components, and if you need more explanation, you can Google it, and as we say always, if you have any question, you can put it into the comments, and I'm gonna answer that. After that, we're gonna talk about CPU development stages. So anything in life is going through development stages, as well as the CPU. So what are the stages of the development of the CPU? First of all, we're gonna talk about Intel series. So let's start. The first one is Intel 4004. That was the first microprocessor can process 4-bit. So this was the burn of the microprocessors. So it was something amazing at the time, I guess. The second one is Intel 8080. It has, or there are other microprocessors showed up from the same family, from 80 family, such as 8088, 8086, and so on. What is this Intel 88 able of? Actually, it's able of processing 80-bit data or word once at a time. So that was amazing, and that was the development, I guess. The third one is Intel 286. It was more developed comparing to the previous ones, which are 88 and 4004, and so it was developed, but in terms of what? In terms of speed and in terms of performance, as well as it can process 16-bit data. And the most important thing about 286 is that they added two types or two essential patterns in this architecture or in this microprocessor. The first one is real mode. So what is this real mode? Actually, it's a pattern inside the 80 to 286 Intel microprocessor that processes data in a sequential way. The second one is protected mode. What does this do? Actually, it was another pattern that processes the data or the information into using parallel processing. So that was a big step. The other one is Intel 8386. It was much better compared to the previous ones, and it could process 38-bit data once at a time. So that was something. As well as it worked with the two previous types, which were the real mode and the protected mode, in addition to virtual mode. The fifth microprocessor that we have today is Intel 8486. It was similar to Intel 8386 with more developments in speed and performance and order specifications. Yeah, it means that they didn't add much in this Intel 8486. The last one on the list today, the last but not the least, it was Intel Pentium. I guess much of you can still remember Pentium. They were used, but not long time ago. It was short time ago. We can remember that they use it. It's like, I don't know, 20 years or something. So this Pentium started a technical revolution. Why? Because PCs, personal computers, were exposed for the first time. So that was something. It was more developed and it could process 64-bit. So it was really amazing, and that's why we understand it made a revolution. And now we're gonna talk about simple introduction to assembly language, and we're gonna talk about details in the next video. But today we're gonna talk about what does assembly language mean and what is its advantages and disadvantages. So let's go. What does assembly language mean? Actually, it's a language that consists of instruction series which are transferred into machine language directly. How awesome that is! It means that we don't need a meditator, and it uses assembler as IDE. What the heck is IDE? IDE is integrated developed environment. Well, what's that mean? It means that if we are using any programming language such as C++, JavaScript, and so on, and we need an integrated development environment, which means that maybe I write the three first letters of any word, and the compiler or the IDE completes the rest. It has a compiler to run the code that we are that you are coding, and so on. So it's an amazing place to code for any programming language. So does assembly language have one? Of course it does. It has an assembler that that consists of all orders and much more that has to do with assembly language. So what do we call this assembler? Actually, we don't call it EMO 8086, and we use the word assembler but not the word compiler. So EMO 8086 is a program, or is an assembler that that provides an IDE for users to code anything that has to do with assembly language. So let's talk about the pros of the assembly, the advantages. There are two basic advantages. The first one, that it works with hardware directly using an assembler, so no need for meditator. As well as it's quick when it comes to execution, due to the fact that there is no meditator. So we're writing a code, then it's being executed as fast as possible. There is no meditator. How awesome that is! But anything has pros, has a cons as well. So what are the disadvantages of the assembly? Actually, there are three basic cons or disadvantages of the assembly. The first one, that it's not compatible, which means if you are coding or writing code on one architecture, it may not work on another, since that every CPU generation is an independent architecture. In other words, if you are writing a code in an architecture such as 8080, and you take that code and you put it in another architecture such as 8086, it may not work, since that there is a rule: every CPU generation is an independent architecture. The second con is that it's complex when it comes to coding, so it needs a lot of concentration, it needs a lot of hard work, and this makes a lot of people not to go to the side of the assembly language, but as I can see, it's really tasty, and it's amazing, because when we talk about its usage in the next video, you're gonna be shocked. The last con of the assembly language is that we're writing a long code for accomplishing a small task. I think that is not extremely courageous and not extremely stimulating, but as we said, if we knew the usage of the assembly language, we're gonna be shocked. It's an amazing language, and it does a lot of work that we're gonna talk about in the next video. I think that was everything for today. We talked about amazing subjects. We talked about the ASCII code, the UNICODE. Then we talked about memory such as RAM, cache, registers. Then we talked about computer itself. What does it consist of? We talked about the hardware, the software, the computer components, and we talked about how any computer works. We talked about the CPU, its definition, and other information, and we talked about the CPU components, its development stages, and then we moved to a simple introduction for assembly language. Sorry, I don't know what's wrong with my tongue today. And then we talked about the pros and cons of assembly. I hope I was good for explaining these interesting subjects, and if you need anything, you can ask me in the comments, and we're gonna meet in the next video. So study well and be prepared for the assembly language. See you guys.